Alright, so at this point, we've essentially covered all of the introductory and user information for the NEC. We've been through the history of the NEC, how it's published and created, and public input and suggestions for it. We've been through the contents of the NEC with various chapters and article organizations. We've addressed some of the information that can be found in the informative annexes, as well as how to use the index. We've looked at how to navigate the definitions that are in with the NEC, which finally has put us in a point in which we can actually begin to discuss some of the rules and requirements of the NEC. The rules in the NEC that we have to follow actually begin in Article 110, General Requirements for Electrical Installations. Now, for it to be the first rule having article in the NEC, Article 110 can be a little bit confusing to understand at first because it seems as though it's just a whole lot of information that's random and not related to each other, all just dumped into one area. However, you can really break up Article 110 into about 5 or 6 key buckets of information. The first one, which we'll be covering in this lecture, is essentially general ideas to keep in mind when installing electrical equipment, such as things as following the instructions or looking at what the equipment rating is, things of that nature. The next bucket is general markings, labels, and warnings that are required for all equipment. Beyond that, you have equipment termination provisions or temperature ratings, which tie into conductor ampacity. After that, you also have requirements for enclosure types. What type of enclosure can be rated for a given installation versus a different one, and a few other things that we will be getting into in our later lectures. So we don't want to overload right off the bat. So starting here in Article 110, if we look at the scope briefly, we can see that Article 110 covers general requirements for the examination, approval, installation, and use, and access to and spaces about electrical conductors and equipment. In other words, again, general use and safety requirements, realistically. A lot of the requirements put in Article 110 are for safe installation. Now, again, this lecture and the first area here, you can realistically put all of these things under one label, which is general considerations for installing equipment. Now, in looking at that, one of the big things to look at is the evaluation of what type of equipment should you use in general. The NEC gives guidelines for this in 110.3a, we can see here. It says the NEC lists there are a variety of things that you should, in general, look at when you're trying to determine what type of equipment you should use for a given installation. So we see some of the things that the NEC notes is number one, does it comply with the code? Number two, the mechanical strength and durability. Is it going to hold up to the environment it's installed in? Wire bending and connection space, the insulation rating, heating effects under normal condition. We have this one highlighted because it will very heavily tie into sizing conductors, which we'll get into later, since all conductor sizing is flat out just based on heat, is really all it comes down to, and a few other things. So again, these are things that we should keep in mind anytime that we're trying to select a piece of electrical equipment. Now again, these are just general considerations for equipment. There's no real directive on us having to do something here. That brings us to 110.3b, which is actually the first direct rule that we have to do something in the entire NEC. And if we look at what that rule is, Part B, installation and use, it plainly says equipment that is listed, labeled, or both, or identified for a use, shall be installed and used in accordance with any instructions included in the listing, labeling, or identification. So in simple terms, the very first rule that directs us to do something that we have to follow in the entire NEC is to simply use the instructions that come with a piece of equipment that we may be installing. So anytime that you're installing a piece of equipment, the very first thing you should do is, if it has instructions, which if it's listed or labeled, it will, you should look at those installation instructions. To go with listing as well on that thought, essentially all the equipment that we install has to be recognized and listed. Uh, Specifically, that listing has to be performed according to Part C here by a recognized qualified electrical testing laboratory. In North America, that is commonly referred to as a national testing laboratory, or a nationally recognized testing laboratory, or a NERDL for short. Now, I had mentioned this when we were looking at the informative annexes briefly, that a lot of people misconstrue this to mean a UL listing, an underwriter's laboratory listing. That is not the case. There are actually over 20 nationally recognized testing laboratories in North America, all of which, at least as far as the NEC is concerned, are equivalent. If a piece of equipment has a stamp from any of those laboratories, we are allowed by the NEC to install that piece of equipment. I wanted to draw attention to that point for an informational note here, that listing is actually maintained by OSHA, the Occupational Safety and Health Administration. So they offer a full list of all the nationally recognized testing laboratories in North America, which you can look up if you're unsure of whether the stamp or listing on a piece of equipment is nationally recognized and would conform with the NEC. Now, moving on again to those just general considerations for installing equipment as well as for using the code in some instances. Some other notes to keep in mind here are for conductors, and this is a conductor / wiring section we can really take into this, is that the NEC recognizes both copper, aluminum, and copper-clad aluminum conductors. Those are the only types of conductors the NEC recognizes, so a lead cable or some of these other older cable types that you may run into eventually in the field or see are no longer recognized by code. Again, needs to be either copper, aluminum, copper clad. And to go with that as well, both in the case of the NEC as well as in the real world, if the type of conductor is not stated for something, then you always assume that it is copper. As we'll see later, equipment has to be identified for what type of material you're allowed to use to connect to it with. So for instance, if you want to land an aluminum conductor under a lug, that lug would have to have a stamp stating that it could accept an aluminum conductor. If that lug does not have a stamp specifically stating that it is acceptable to use aluminum with it, you can only assume that copper is the only conductor allowed to be used with it. Moving on from there, as far as the NEC is concerned, wire sizes will be expressed in either an American wire gauge or a circular mill. Obviously, we have American wire gauge up to a 4/0, which we'll see a bit later once we get into some of our conductor tables. Anything larger than a 4/0 will be a KC mill, and the NEC recognizes wire size up to 2,000 KC mill, nothing larger than that. Now, sticking again with the general wiring section here, we're at 110.8 that this section provides. Any of the type of wiring methods that the NEC states are permitted to be installed in any type of building, occupancy, or wiring system. Meaning, in essence, if we take, for instance, EMT, which is an article and a recognized wiring method in the NEC, you're allowed to install EMT in any type of building or structure. Now, there may be some specific areas or installation types in which you could not install that. So, for instance, in a commercial building, you'll always be allowed to install EMT in, say, a warehouse. But if that warehouse were to have explosive materials that made it a classified location, you wouldn't be able to install EMT in that classified area. However, there's nothing about the building itself that would prohibit you from installing the EMT. Rather, it would be the use of the building that would prevent you from being able to do that. So just a general note. On that same note, the NEC will not recognize wiring methods that are limited to a specific installation. One of the most common examples of this is URD cable, which you may see at a big box store, underground residential distribution cabling. That specific type of cabling isn't recognized by the NEC, since the manufacturer only allows it to be installed in residential applications. Now, that doesn't mean that you can't install it. It just means that the NEC will not have specific provisions for that cable in of itself. Generally speaking, when that's the case, that installation on that conductor will have a rating that is recognized by the NEC. Such again is the case with URD, in which case you would then just follow the NEC requirements as they apply to that conductor type. Again, sticking with our wiring means and methods here, another consideration that the NEC looks at is, again, the identified use of that in terms of the area. So if we look here, we're not permitted to install any type of wiring method or conductor in a damp or wet location or where exposed to gases, fumes, vapors, etc., unless that item is specifically identified for use in that area. In other words, if we want to install a conductor in a wet location, that conductor has to be identified as acceptable to do so. And that's a very common thing. So, for instance, THWN is denoted as being allowable to be installed in a wet location. This isn't some type of oddball requirement, and it's something that's often overlooked because it's so common in the industry, but that is an NEC requirement. Another requirement that you'll very commonly see in the NEC that isn't listed here is for exposure to sunlight. Equipment that is exposed to direct sunlight also has to be identified as being acceptable to be installed in that area as well. We run into that a lot with tray cable and PVC conduit specifically. So that wraps up kind of the little wiring section of this first bit of Article 110. Now there's still a few things that we're going to cover during this lecture that to me get rolled into those general installation requirements. A good one to point out here is 110.12. I always like to point out this reference in mechanical execution of work. It is actually a code requirement in the electrical industry, as you can see here, that electrical equipment has to be installed in a professional and skillful manner. Now, that is a bit open to interpretation as to what that would mean, obviously. What one person may think is good and fine for installation could be different for another person. However, the NEC doesn't give specific guidelines of what is good or bad. They do point you to ANSI and NECA standards for what good workmanship in the electrical industry does look like. So this could be used as a reference of, generally speaking, what that should look like. Now, if we move on to the next page, this will be the last point that we address in this lecture, again, for general installations. After that, we'll be moving on to our temperature ratings and opacity ratings for terminations. And this bleeds a little bit into terminations, but again, I do kind of include it in the big bucket of general provisions to keep in mind for electrical. Is that any type of device that we're going to be using to terminate a conductor, as I mentioned earlier, has to be identified for the material that can be used on it. And another point to make here is that if you notice, past our highlight, conductors of dissimilar metals can't be intermixed unless the device is identified for that purpose. So we would not be able to, for instance, put an aluminum and a copper conductor under the same lug unless that lug was specifically rated to do that. Again, the NEC is very generally speaking big on having to have things identified for what you intend to do with them. So as a recap, if we come back up to our first page in section of 110, to summarize, we more or less covered that the NEC gives general recommendations for what to evaluate when you're looking to install electrical equipment. It states that you have to have equipment listed and labeled by a nationally recognized laboratory, and that once that nationally recognized laboratory provides instructions for the equipment, you have to follow those instructions. It states that you can use copper aluminum or copper clad aluminum in either American wire gauge or circular mill sizes, and that you're allowed to install those wiring methods as identified by the NEC in any type of building. However, depending on the exact location in the building or the application that you're using them in, that conductor or equipment may need an additional listing or labeling for that, such as the case with gases, fumes, vapors, direct sunlight, excessive temperatures, etc. And it tells us that as we're doing those installations, we have to do them in a skillful, professional manner. And that concludes what I would consider the first grouping of the Article 110 requirements. As I said, there's a couple groupings that you can break into sections within Article 10, and that's the first one. Next grouping of Article 110, we're going to be looking at 110.14c, which are these temperature limitations for equipment here, which we'll get into again once we look at our ampacity tables in later lectures. This information will very heavily relate to that.